Welcome to Astronomy Daily, your go-to podcast for the latest in space and astronomy news. I'm Anna, and joining me, as always, is my co-host and fellow space enthusiast, Avery. How's it going, Avery?
Hey, Anna, and hello to all our listeners out there. I'm doing great, especially with today's lineup of stories. We've got some exciting developments from rocket tech to cosmic mysteries. It's like the universe is putting on a show just for us.
Absolutely. Today, we're diving into 5 fascinating updates. A German company's push to revolutionize European space launches, a new armor tech to protect against space debris, insights into how black holes fire off powerful jets, a surprising twist on white dwarf stars, and a tale of a mistaken gold nugget that's actually from outer space. We'll break them down, discuss what they mean, and keep things real with the science. Let's jump in.
First up, some big news from the European space scene. HyImpulse, a German rocket builder, just announced they secured Euro 45 million in funding to speed up development of their SL-1 rocket. This 3-stage beast is 33 meters tall and can haul up to 600 kilograms to low Earth orbit using hybrid motors fueled by paraffin and liquid oxygen. They're aiming for a debut flight in 2027, and they've got an optional space tug called HyMove for dropping payloads into different orbits.
That's impressive. HyImpulse's CEO, Christian Schreier, said this will help make Europe more independent and competitive in space access. But let's put this in context. Europe already has heavy hitters like Ariane 6, which can lift over 21 tons in its beefier version, and Vega C for up to 2,300 kilograms. Still, with only a handful of launches this year due to delays, there's room for smaller, more agile options like SL-1 to fill gaps, especially for smaller payloads that might otherwise hitch a ride on foreign rockets.
Totally agree. It's not about replacing the big guns, but adding flexibility. Europe accounted for less than 1% of global launches in 2024, per recent reports, partly because some missions went to SpaceX. If HyImpulse pulls this off, it could reduce the dependency and boost the continent's space economy. Exciting times for European rocketry.
Moving on to protecting our assets in orbit, Atomic 6, a Georgia-based company, has unveiled Space Armor, a new composite material designed to shield satellites and astronauts from space debris. This stuff is lightweight, comes in customizable tiles, and unlike traditional metal shields, it absorbs impacts without creating secondary fragments.
Yeah, space junk is a huge problem. Millions of tiny particles zipping around at over 16,000 miles per hour. The old Whipple shield, invented back in the 1940s, sacrifices itself but spits out more debris, worsening the Kessler syndrome, where collisions snowball. Space Armor uses a fiber-to-resin method to dissipate energy cleanly, and it's transparent to radio signals, so it won't mess with comms.
CEO Trevor Smith said it took 18 months to develop, and tests showed it handling Mach 21 impacts with zero debris. They're planning orbital tests next year using real debris as natural hypervelocity guns. This could be a game changer for safer missions, especially in crowded low Earth orbit.
For sure. Imagine suiting up astronauts or encasing satellite batteries with this. Lighter, stronger, and debris-free. It's a smart evolution in space tech, building on composite's potential to make orbits more sustainable. Now, let's get cosmic with black holes. Researchers at Goda University have used advanced simulations to explain how supermassive black holes produce those massive relativistic jets, streams of plasma shooting out at near light speeds, stretching thousands of light years.
The key is the Blandford-Znajek mechanism. A spinning black hole twists magnetic fields in its accretion disk, converting rotational energy into electromagnetic power that launches the jets. But the new twist? Magnetic reconnection, where field lines snap and release energy, plays a big role too, creating plasmoids that boost the process.
Their Frankfurt particle and cell code simulated this on supercomputers, showing how these events extract energy efficiently. Professor Luciano Rizzola noted it explains the extreme brightness of active galactic nuclei and particle acceleration. Observations like the Event Horizon Telescope's image of M87's black hole back this up, with its jet extending 5,000 light-years.
This isn't just cool. Jets influence galaxy evolution by dispersing energy and affecting star formation. It shows black holes as dynamic engines, not just sinks. Dr. Claudio Maringolo said these SIMs reveal the interplay of gravity and magnetism and extreme environments. Mind-blowing stuff. Shifting to stellar remnants, astronomers have figured out why some white dwarfs in short-period binary systems are inflated twice as large as expected and hotter, up to 30,000 Kelvin, instead of the usual 4,000. These are dense cores left after stars like our sun die, but in pairs orbiting in under an hour, they're far from dead.
The secret is tidal heating. Gravitational tugs deform the stars, causing internal friction that heats and expands them, especially the less massive one. Lead researcher Lucy McNeil developed a model showing this lets interactions start at longer orbital periods, up to 3 times what we thought.
Observations of these hot, puffy white dwarfs match the predictions. McNeil was surprised by how much orbits shrink for the oldest ones before mass transfer kicks in. This could reshape our understanding of Type 1a supernova progenitors. These binaries might merge into those cosmic explosions we use to measure distances.
Exactly. It applies tidal heating from hot Jupiters to white dwarfs, showing binaries keep evolving dynamically. Future work on carbon and oxygen white dwarfs could refine supernova models. White dwarfs, not so dead after all. Finally, a fun one. Back in 2015, Australian prospector David Hole found a heavy reddish rock in Maryborough Park. Thinking it was a gold nugget, he tried everything: saws, acid, even a sledgehammer to crack it open, but no luck.
Turns out it was a 17-kilogram meteorite. Museum geologists identified it as an H5 ordinary chondrite, packed with iron and chondrules, ancient grains from the solar system's birth 4.6 billion years ago. It's the second largest in Victoria, where only 17 meteorites are recorded.
Carbon dating places its earthfall between 100 and 1,000 years ago, possibly linked to historical fireball sightings. Geologist Dermot Henry called it a cheap way to explore space, with potential organic molecules hinting at life's building blocks.
From gold rush disappointment to cosmic gem, its dimpled surface and density gave it away. Likely from the asteroid belt, it's a reminder that treasures can fall from the sky. What a story.
Ooh, what a packed episode. From rocket boosts to meteorite mix-ups, the universe keeps delivering.
Thanks for tuning in to Astronomy Daily. If you enjoyed, subscribe and share your thoughts. We'll be back tomorrow with more stellar news. Until then, keep looking up.
Clear skies, everyone.